Hello, 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 everybody, and welcome back. We are looking at B2 on our 2015 Canadian Open Mathematics Contest, or I guess they say Mathematics Challenge, same sort of thing. It's just math for the sake of math. It's just fun, and hopefully we've got a fun question here in B2. Let ABC be a right angle triangle with BCA equal to 90. So already I'm going to try and do a little picture. A, B, C, shall we? Because the C in the middle tells me that C is where the 90 degree is. A circle with diameter AC intersects hypotenuse AB at K. If BK to AK is 1 to 3, the measure of the angle BAC, so this angle up here is, we'll find the measure of BAC. Okay, so I have these sides and the arrangement slightly wrong. So we'll do a CA here and then a B up here, just so that we get the bigger arc, and so the bigger side is 3 to 1. So what is a ratio of 1 to 3 mean? So if I called this length x, this would be 3x. Okay, that's the idea behind what we've got here. Okay, so what can we do here? What do we want? We want the angle at A. That's what we're interested in. How can I figure out the measure of that angle? Well, let's see here. A couple things that spring to mind. All of this is going to be sort of circle geometry, so it's very good to know circle geometry. If I have a point and it subtends an angle, let's call it, so our angle up here, and I can it subtends a chord with an angle here, and I connect the end points of the chord up to the center of the circle, then I get twice the angle. So how would this be relevant? Well, if the semicircle that I've got is placed on AC, AC is the diameter, then the midpoint there is going to be this what do I want to say? The midpoint is going to be the center of the semicircle, and so we could connect it up here. And the chord that I'm talking about, just to use a different color, is this CK chord. So whatever this angle A is, let's call it theta, the angle here will be 2 theta. And so that's what I'm thinking about. Although now that I've written that, well, we're going to have a radius for our circle here. Now the radius is appearing in lots of different places. Okay, we can actually get the angle theta will be up here as well, because we've got a nice little isosceles triangle. We've got another isosceles triangle here. Now this is all circle geometry. Where am I using the 3x and the x? Well, I haven't used it yet. I have not used it yet. I'm trying to think of a good way to use this ratio. Nothing's immediately springing to mind, but if I go back to another circle geometry result, if I have a point outside a circle and 2 points on the circle, and I connect them up, well, let's draw a slightly better picture. So if we've got a tangent, so BC is tangent to the circle because it makes a nice little right angle here. If we imagine the rest of the circle, BC just sort of touches it once. And then we've got this nice little chord here. Well, there's something called a result called, I think it's called cross ratio or power of a point or something to that effect. If we got a point out here, a tangent point, or if we got chord points here, turns out that PT squared is the same as px times py. And of course, if we had another pair of points on here, say w and v, this would also be equal to pw times pv. So there's this nice constant relating just to the circle and to the point wherever it is. So how does this help me? Well, if I want to use this result, bc squared should be the same as bk times ba. But bk is x, and ba is x plus 3x, so 4x. So bc is 4x squared, and I think we're getting a lot better now, because then bc would be 2x. So maybe my first circle geometry instinct wasn't right, but okay, we got this 2x here. So how does that help me? Well, I want this angle theta. Yeah. Okay, we definitely have the answer now. We don't need any of this stuff in here, but that's okay. I'm just, point of these videos is trying to show off how you might think through the problem. That doesn't mean we're always going to get it right first time. Okay, and maybe the next time you see a question, you'll need this, this angle chord, we call it the Star Trek theorem, result. But we don't need it this time. Okay, we want theta. Well, what have we got? We have the side opposite theta. We have the hypotenuse. And so you might remember from school SOHCAHTOA. It's how right angle triangles are related. So if I've got an angle here, we call O the opposite side length, A the adjacent side length, and H the hypotenuse. Always sort of remember this. SOHCAHTOA. What do you do when your foot's on fire? You SOHCAHTOA. And the relationship here is S tells you that sine of your angle has the same value as the opposite length divided by the hypotenuse length. Well, we've got these values. The opposite side is 2x. Divide by h, which is x plus 3x, so 4x. And we get 1/2. So sine of theta is 1/2. Now what angle has theta being sine theta being equal to 1/2? Well, it's going to be pi by 6, or you might better know it as 30 degrees. And either answer would be acceptable. Okay? Pi by 6 or 30 degrees is going to get you just fine. Just fine. Okay? Another way to see it instead, if you didn't want to use sines and cosines, another thing we could do is say, what have we got? Well, we've got 2x here and 4x here. Well, hypotenuse is just twice this side length. And we could figure out the other side length as well. It's going to be 2 root 3x. Just use the Pythagorean theorem. I'd show it off, but I've already finished the question. I'm just trying to show you another way to do the question. And so what have we got? Well, the sides now are in the ratio of 1 to... Let's draw my triangle a little bit better. The sides are in the ratio of 1 to root 3 to 2. And this might sound familiar to some of you. This is a 30, 60, 90 triangle. So that's another way to see it's 30 degrees. And we don't have to have a whole lot of trigonometry memorized. If we just remember 30, 60, 90 triangles come up a lot on contests. And knowing that their sides have the ratios 1 to root 3 to 2 can save you even if you don't remember trigonometry. Okay, and I always try and avoid trigonometry when I can. Because, you know, for a contest like this or the Canadian Intermediate or the Canadian Senior, not everyone's seen all aspects of high school math yet. So I try and show off a variety of methods. So we could use SOHCAHTOA, reverse sine, or we could say, well, gee, the ratios here are going to be 1 to root 3 to 2. This is a 30, 60, 90 triangle. You know, some of the grade 8 students I work with know about 30, 60, 90 triangles, even though they have no idea what sine and cosine and tangent are. Okay? So 30 degrees or pi by 6, if we're familiar with radians, is going to be our answer. And, yeah, that's all I've got to say. So up next, we're going to do more of the B part of our what are we at? The 2015, right? Yeah, the 2015. So it'll be B3. I will see you for that in the next video.